In our last video, we'd imagined that we had invented or developed or proved the Pythagorean theorem, and we were then developing a piece of software to embody this contribution, allowing people to, other researchers, other users, to plug new numbers into that, to use it in their own research and potentially build on it. And we started off by building a very, very basic version of this theorem in code, one that simply compiled, but wasn't particularly sustainable in the sense that it didn't adhere to good coding practice. So we did a number of iterations where we made it more and more adhere better and better to coding practice, and thus was more sustainable. We added things like descriptive variable names, we added comments, we added exception handling, and we added a separation into classes. So there's a lot of coding there, and hopefully you've been coding along. It's the best way to do these things. Watch me typing it out, follow it along, or jump ahead if everything's making sense. But do make sure you sit down and actually write things out, and not just watching along. And so if there are bits that were tricky as you were going along, do go back and watch them again, maybe the things on class structures, and even write separate programs of your own that follow the similar conventions in order to really test things out. But we have done a lot of coding, so it's just a little bit of a step back, a little bit of a break from the coding from this video, because we now know about the concept of version control. We know that having a versioned piece of code lends itself to sustainability because it gives an idea of how we've constructed things, so it makes our code more extendable because you can see where we've come from in terms of developing this code. So in order to version our software, so if we look back at the code that we produced last time, so we're now at quite a nice place. It would be really nice to be able to make a version here, to make a mark that says, this is at the point in the development of this code where I was happy, where we had a fairly complete solution. And I want to make a record of this before we move forward. Mainly, like I say, so we can have a tracked history of what we've done, but also in case things go wrong, so we can roll back to where we were. And also to enable nice things to happen, such as branching that we talked about briefly. So multiple people could now come along and continue developing this code in different ways, different coordinated ways, and then bring that all back together in terms of merging. But what do we do here? So what is Git? Well, Git is much like Python, is a command that we invoke from the command line. So again, using the old version trick, I'm calling Git here. I'm asking it about its version. That's the parameters that I'm passing, and it's giving me some information back, so I know that Git's working. So again, something that I call from the command line. So to use it, I need to make sure that I'm in the right directory. Issue the listing command. It shows me, yes, I'm where I think I am, and everything's okay, I'm in the right place. So what's the flow? Remember the flow from the slides. We want to actually now make a record of where we are. What do we do? Well, first of all, we need to tell Git, we need to call Git into operation. We need to say this is where Git is going to be working. So from within the directory where the files are that I want to make versions of, I issue this Git initialization command, Git init, and that will now tell Git that this is my workspace. This is eventually going to be my repository with commits. And I can see here inside the graphical file structure that Git's created its own little folder now where it's going to keep all the important, useful information about the versions that I have. The second step of the flow is to now actually add all my files to the staging area. So remember, we have a two-step process when we want to actually make a record. First we stage and then we commit. And the reason that we have this intermediate step is it's so we can pick the files that we want to add to our commit, the files that we want to actually track within this commit. And in this case, you can see I've got three main things beyond the Git folder within my Pythagoras directory. You can see that I've got this pycache folder. This is something internal used by Python as a part of the kind of compilation process, as it were. And then I've got my actual files that contain my code, which is Pythagoras and theorems. So I don't really want to be adding the pycache folder. That's not really anything to do with me. I don't want to be adding that to my Git history. And so staging provides me with the opportunity to do that. Now, it's worth saying, typically I would avoid these things happening using a git ignore file, but for now, for simplicity, we're going to do this simply by staging. So what I'm going to say is I want to add to the stage. I'm going to say git add, and I want to add everything that ends in the extension py. So all of my Python files. This is a wildcard. This matches anything plus dot and then py. So that's obviously just Pythagoras and theorems. So I'll go ahead and run that. And yeah, then we can say Git hasn't said anything, so we now know that everything has gone successfully. Everything has been staged. So what's the next step? Well, now we want to go ahead and commit. So we want to take everything from the stage and include it in the record that we have. So how do I do that? I say git commit. I'm going to use this M flag, and that's going to say that, because I have to do this is an important part, and this is why Git is so good for sustainability, because it forces you to actually annotate the records that you're making. And I'm going to say, give a message about what happened in this commit. What does this commit relate to? I'm going to say initial Pythagoras implementation. Okay, so everything's staged. I've initialized my Git repository. The files that I actually want to track have been staged, just the 2 Python files, not the py cache. And I'm now going to make a commit. I'm actually going to make this mark in my history of where I'm up to. I press enter. It's told me 2 files are changed. That would be Pythagoras and theorems, as I can see. And there are roughly 29 insertions, which I believe correspond to the total of the 2 lines across the files. And that is more or less it. So I've now made this record. This exists. And if I do something like git log, I can see, great, here's my initial Pythagoras implementation. It's the message that I wrote. It's got a unique ID. And then as obviously I proceed and I add more things, I make more changes, I do more commits, and I start building up this history that we're talking about of the commits that I've made. It's also really nice now because I have a safe place to come back to. So let's imagine that, heaven forbid, everyone deletes everything in my Pythagoras file. What I can actually do now is issue this. I can say git reset hard. Now do be careful with the hard flag. This will actually modify the files in your folder, as opposed to something like mixed and soft, which will just move the pointer in the git history, as it were. And but this is actually what I want to do in this case, because I want to bring back the code that I lost. So I go git reset hard, and it will bring me back to my last safe place, which was this Pythagoras implementation. So that's quite nice. And then I could do stuff like git branching. So if I do something like git branch, then it shows me the branches that I'm on. I could make new branches and merge things back in if I had different branches, and all sorts of fun things there. But yes, that's the basic form. So this is git locally. This is a complete flow in that sense, a local git flow. But we have talked about a final step, which is maybe pushing this code off-site. And to push code off-site, we're going to rely on a service like GitHub. So this may be public GitHub, github.com, or it may be an enterprise service. Both work more or less the same way. And so what we're going to do is we're going to create a remote repository on the GitHub service, again, be it public or enterprise. And then we're going to, what we call, push our code to this service. So we are going to say, this is from the main GitHub page. We're going to say new. We've got to give our repository a name. We're going to call it theorems. We're going to keep it private. And then we're going to go ahead and we should add a description really, but we can leave that for now. And we're going to create the repository. So now we've created this space within GitHub where we can store a copy of our Git repository. And to do this, we actually have to obviously connect to the site. We have to connect our local repository to this remote space. And to do that, we can use HTTPS or SSH. Strongly recommend that you use SSH. And to do that, you need to do something called generate SSH keys and add them to GitHub. It's not something that I'm going to go through. Again, the top hit on Google is GitHub's own pages where they describe in great detail how to do this. I recommend you go through that process, add those SSH keys in so that you can get this simple flow of connecting to your remote repository. So assuming you've been through that and all the SSH keys are set up fine, we can then just copy this link. And then it's just a case of going back to our code. And what we will do here now is we will connect this local repository to the remote one. And we're going to do this by saying git. We're going to say we're dealing with a remote repository. We're going to say we want to add a new repository. We're going to give it a name, typically the original. The first repository we call origin. And then we're going to add in our link. Going to go ahead. And again, Git hasn't complained, so everything seems fine. And then we simply just go ahead and push. And this is actually Git's going to complain now. But that's nice because it shows us that it's going to show us the power of Git helping us out. So we now try and push all this code up. We take it from local to remote. And Git, as I say, gives us this error. It's saying actually the branches, like we saw here with master, isn't linked to anything remote. We need to actually say which branch effectively we want to push. It's going to link the local branch to the remote or upstream branch, as we call it. So we can just go ahead and very handily through what Git offers us, use this command that it recommends, git push, and everything goes up. So now if I go back to my remote repository, I refresh, I can see here we go, I've got a copy of all my code here. This is really good because this now facilitates code sharing and sort of making almost a record of the code that you've created, which again all feeds into open science and sustainability, nice things like that. So we can now explore our code. This is exactly what we wrote, Pythagoras. We can see a record of our commits that we've written, and again we can do interesting things. So within settings, for example, we could add in collaborators. We need to re-log in for that, but that's how we would do that. And there we go. So that's the Git flow. That's how you would go about using this formal version control process. You initialize your Git repository, you add those files that you want to the stage, you then make your commit, and that's okay for a local Git process. But if you want to take that one step further and take take your repository off site, you would initialize this remote location, push everything up, and then everything's then stored in the remote repository, and you can invite collaborators, etc.